Hello and welcome to sixth semester. Also, I welcome you all to the subject Introduction to HVAC. What do I mean by HVAC? Heating, ventilation, and air conditioning. So, this subject, which includes 6 units. First unit is Introduction to Refrigeration. Second one is Introduction to HVAC system. Third one is Thermal comfort. Fourth one is ventilation and indoor air quality. Fourth one is hydronic system. And last one is application of refrigeration. So let us consider Unit 1, which includes definition of refrigeration, laws of refrigeration, method of refrigeration, refrigeration effects, COP, turn of refrigeration, difference between refrigeration and heat pump, VCR system, VCR cycle, principal parts of a single VCR system, then representation of this VCR cycle on pH, TS and PV diagram, then factors affecting the performance of a VCR system, then household refrigerator working on VCR cycle, then refrigerants, essential properties of refrigerants, then selection of refrigerants, then simple vapor absorption refrigeration system, then difference between the absorption system over a compression system. Now, let us consider the basic things. First one is definition of refrigeration. See, refrigeration may be defined as the process by which the temperature of a given space or a substance is lowered below that of the atmosphere or surrounding. The system maintained at the lower temperature is known as refrigerated system. This is the space refrigeration system, while the equipment used to maintain this temperature is known as refrigerating equipment. In order to maintain a temperature below the surrounding atmosphere, it is essential that whatever the amount of heat gets into refrigerator space must be extracted out to maintain the desired temperature. See, this is the space to be refrigerated, and this is nothing but the refrigerating equipment. See, for anything which is governed by some laws, that is, the refrigeration is bound by these laws, are first one is fluids absorbs heat while changing from a liquid state to vapor state and give up heat in changing from a vapor to a liquid state. This law applies in both the case, that is condenser and evaporator. Next one is temperature at which a change of state occurs remain constant during the change, provided the pressure remains constant. This law also applies in both condenser and evaporator. Third one is heat by itself flows only from a body which is at a higher temperature to a body which is at a lower temperature. This law also applies in both condenser and evaporator. Next, fourth law is metallic parts of the evaporating and condensing units are metals which have a highest heat conductive qualities. Last one is heat energy and other forms of energy mutually convertible. For example, electrical energy may be converted into heat energy and heat energy may be converted into electrical energy. Similarly, heat energy may be converted into mechanical energy and mechanical energy into heat energy. This law applies for both electrical and motor and compressor. Let us come to methods of refrigeration. There are 10 types of refrigeration system, out of which vapor compression refrigeration and vapor absorption refrigeration system are important for the subject point of view. Let us read about these refrigeration methods. First one is ice refrigeration, second one is dry ice refrigeration, evaporative refrigeration, air expansion refrigeration, gas throttling refrigeration, steam jet refrigeration, liquid gas refrigeration, vapor compression refrigeration, vapor absorption refrigeration, and last one is thermoelectric refrigeration. As I told earlier, vapor compression refrigeration and vapor absorption refrigeration are very important part for the subject point of view for HVAC, that is heat, ventilation, and air conditioning system. So let us know what is a refrigeration effect of a machine. The cooling effect produced by a refrigerating machine in a given time is known as its refrigerating effect. It is expressed in kilojoules per second. This is the cooling effect in kilojoules, and the seconds is the time, given time. So always the refrigeration effect will be expressed in the form in the unit of kilojoules per second. Let us know about coefficient of performance. The term coefficient of performance has been devised to measure the effectiveness of a refrigerating machine. It is defined as the ratio between the refrigerating effect and the heat equivalent to work supplied to the refrigerating machine. So COP is equal to refrigerating effect divided by work done. That is K is equal to N divided by W. So which will not be having any units because N is equal to net refrigerating effect or cooling effect or heat extracted in kilojoules per second. W is equal to work input to the machine. It is also expressed in kilojoules. So K is equal to N by W. So these two cancels. Kilojoules per second cancels. The COP is always expressed as a unity. So in most of the cases, COP will be much more than unity. If N and W are actually measured during a test, their ratio K will be the actual coefficient of performance. The theoretical value of N and W may be obtained by applying the law of thermodynamics to the refrigeration cycle. The value of K thus obtained is known as the theoretical coefficient of performance. The ratio between the actual and theoretical coefficient of performance is known as relative coefficient of performance. So let us know about a ton of refrigeration. So let us know, due to the fact that in early stages refrigeration was produced by ice, the rate of removal of heat in a cooling operation was expressed in terms of tons of ice required per unit time, usually per day, that is for 24 hours. Thus, standard unit of refrigeration being used is ton refrigeration or simply ton, denoted by the simple TR, ton of refrigeration. In FPS system, the latent heat of fusion of ice is 144 of BTU, that is British thermal unit per pound, which means that 1 pound of ice absorbs 144 BTU of heat when it melts. One short ton, that is 2000 pounds of ice, therefore absorbs 2000 into 144 or 288 000 BTU of heat. In order, in other words, when 1 ton of ice melts in 24 hours, it will produce a cooling effect of the rate 288 000 divided by 24 or 24,000 BTU per hour or 12,000 per 60 is equal to 200 BTU per minute. Thus, this rate of cooling has been designated as a ton of refrigeration. So, a ton of refrigeration is not the unit of mass, but it is the measurement of the rate of heat transfer. In case of MK system of unit 72,000 calories per 24 hours or 3000 calories per hour or 50 calories per minute rate of cooling measure 1 ton refrigeration. Hence, a machine having its capacity to produce cooling effect of 200 BTU per minute or 50 calories per minute is classed as 1 ton of machine. The difference between refrigeration and heat pump. There is no difference in the cycle of operation between a refrigerating machine and a heat pump. In other words, the same machine can be utilized to work either as a refrigerator or a heat pump. The main difference between a refrigerator and heat pump is of the purpose or desired effect expected. While refrigerator is used to produce cooling effect and a heat pump is used to utilize the heat delivered at high temperature for heating purpose. Another essential difference which could be physically conceived from the fact is that in a refrigerator there is pumping of heat out of system or confined space as as against the pumping of heat from the surrounding to the system in the case of heat pump. This is the surrounding and this is the system or confined space to be cooled. So this is T1 and T2 where this is the refrigerator. This is the work input or WR to operate the refrigerator. Whereas in case of a heat pump, this is the system or space of to be heated, and this is surrounding. So this is the work input to operate the heat pump. That is the difference between refrigeration and heat pump. Thank you.